Okay, so term 11 is negative 2 times negative 3 to the 10. So this, if you put it in the calculator, should be negative 118,098. So it should be B. Did anybody confirm that for me? Okay, so I think I had it in the calculator wrong the first time. Common ratio, you can take any term divided by the previous. So for example, negative 36 over 48 works just fine. That's like negative 3/4. So the answer should be B. Determine the number of terms in the geometric sequence. Well, we want to know, where does 2048 equal to 1 over 128? The common ratio in this case, I'm timesing it by 4 each time. So that means I end up with 262,144 equals 4 to the n minus 1. That's pretty large numbers, so I'm probably going to want to use logs to solve that. So the log base 4 of 262,144 equals n minus 1. 26. So I end up with n equals to 10. A geometric sequence has a common ratio of 2. The 12th term is 16,384. So we want to find the first term. Well, this is just, again, reworking the formula. So 16,384 equals to the first term times 2 to the 11th. So that means 16384 divided by 2 to the 11. So A equals to 8. Okay, the next one may have been a little trickier. Anyone have a strategy for dealing with this? Did anybody get an answer for number 5? Okay, well, what was your strategy? Robbie, tell us.
I took K divided by 8 and I took 20 and divided by K.
That sounds like a good strategy to me. So the common ratio is either K over 8 or 20 over K. That number must be the same if it's going to be a geometric sequence. So that means this must be true. K squared must be 160. So that means K is plus or minus root 160, which 16 times 10, so I can pull out 4 root 10. And this is one of the possible answers here, for root 10. The other possible one would have been negative, but it wasn't given as one of our choices. Let's see here. 4 root 10. Okay. Okay, the third term in a geometric sequence is 48. The sixth term is 81 over 4. Find the first term. So to work on this one, the strategy we had talked about was to make a fraction. So term number 6 is 81 over 4. And term number 3 is 48. So if I simplify this out, that means r cubed is going to be 27 out of 64. So r must be equal to 3/4. Oops. Oh, first term. Right, thank you. Sorry, I'm trying to rush a bit because we're a little strapped on time. So now that I've got a common ratio, I need to take it and figure out the first term. So why don't I use the fact that the third term is 48. So AR squared equals 48. That means A times 3/4 squared is 48. So 3/4 squared divided by 48 divided by, so I end up with 256 over 3, which is C. Okay, the general term of a geometric sequence is given there, 5 times 2 to the n minus 1. Determine the sum of the first 15 terms. So all you have to do is interpret this as a, the first term, and r, the common ratio. So if I want to sum up 15 terms, S15 will be 5 times 1 minus 2 to the 15 over 1 minus 2. So provided that I can put it in my calculator properly, I end up with 163,835, which is C. Okay, so this next one, maybe I'll go a little slower. How many people were able to get an answer for 8? Good. So it's a tough one. One strategy you're going to find in math that pays off huge is sometimes when you have no idea where to start, the best thing to ask yourself is, what's one thing that I can do? That's it. You look at it and you go, I have no idea what this even means. What's one thing that you could do to this that maybe, if we did just one thing at a time, would sort of lead us somewhere we might be able to find an answer? I do it all the time. There's times when I look at something and I have no idea where to start, and I just take the first step. And then eventually I take another step, and I'll find my way through to the answer, just sometimes by luck doing it that way. So does anybody think of one thing we could do here? Yeah, that's the thing that you want to do is, if you ask yourself, what do I not like about this question? You're probably going to say, I don't like that. If that was normal and it wasn't, a sigma notation, I'd be happier. So that's probably the first thing we want to change. So let's write this out. It would be x plus 1 plus 2x plus 1 plus 3x plus 1 plus 4x plus 1 and stops at 5x plus 1, and it equals 211. So now that that's out of the way, I think at this point all of you would be able to solve this. It's just that first step, right? So when something bothers you, ask yourself, what bothers me about this question? What could I do to change that? What bothers me? Okay, so I'm going to collect up like terms. That means there's going to be 1, 2, 3, 4, 5. Move that to the other side will be 6. And there's 1 plus 2 is 3, 6, 10, 15 x's. So that means x equals 6 over 15, which as a decimal is 0.4. Okay, free marks here. Determine an expression for the number of terms in the series. Okay, so there it is, top number minus bottom number plus 1. So b minus a plus 1, which gives me c for the number of terms. Okay, infinite series. When we do infinite series, the first thing you got to ask yourself is, does it make sense that this will have a sum? So what do you think? Will this have an infinite sum? Well, it's past 9 o'clock now. It's 9:30, right? Will it?
Yes.
Okay, there are 3 people awake in the class. Thank you to those 3 of you. So yeah, it will have a finite sum. How did you know that, Ming?
It shows less than 1 and greater than -1.
Yeah, or all you needed to say was it was -1/3, right? So if I want to figure out then what the infinite series is going to be, first term divided by 1 minus -1/3. So that's 3 over 4/3, which will be 9 over 4. So B is the answer. Okay? So one thing, the reason you always got to ask yourself, will it have a sum, is usually this is an option. There is no infinite sum for it. That could be one of the answers. So you should always double check before you use that formula. Okay, the sum of an infinite geometric series is 9. The common ratio is -1/3. Determine the first term. So this is a nice question. This formula is a lot easier to work with. So that means 9 equals a over 4/3. So if I multiply both sides, 9 times 4/3 will equal to a. So 36 36. So 36 over 3 equals A equals 12. Over 3. Okay. So number 12. Logarithms. So we're not quite through with logs. They do pop up on the odd occasion in the rest of the units. I guess they like to torture you a little bit more. So it's not quite over. Determine the common ratio. We could take any number and divide it by the previous. Why don't we take the smallest two, 9 and 3? So the common ratio is going to be log 9 of A over log 3 of A. Make a better 9 here. So this is, okay. So does anybody have a bright idea on how we would go about figuring out this question? Sure, Jeremy. Yeah, that's one way you could do it. That's good. Not everybody will see it that way, but basically, the common ratio has to work for any of the numbers that we pick. So if we were smart and we pick a real good number, we might not need to do anything, any complicated math. So Jeremy's suggestion is let A, see if my pen's busted, just a second. So let's take a look and see what happens then if we do let A equal 81. Okay, how did you come up with that number?
I just saw 3981.
You just saw 3981. Can anybody tell me why 81 is a good choice? How about now? Can you tell me why 81 was a good choice? Yeah.
The answers of the two get whole numbers.
Sorry?
The answers of the two get whole numbers.
Yeah, they're whole numbers. They're easy to calculate. We don't need the calculator. So this is squared, so it's 2. This is fourth, so it's 4. So 2 over 4, which is 1/2. So, I mean, it'll still work if you pick A equal to 100, but you're going to need a calculator for that. You might not be able to do it, well, I almost guarantee you won't be able to do it without a calculator. Let me show you what the people that designed this question would have had in mind. It's different than that. The people that had this in mind, the question in mind, had a different strategy. Can anybody tell me what they might have been expecting you to do? What's wrong with these two logs and that fraction? Why can't we simplify it? Different bases. So if we want to do some operations, we'd have to have the same base. So that's what I'm going to do is I'm going to turn them into both base 3. So that means I'm going to have r equals log base 3 of A divided by log base 3 of 9. And then I still have log base 3 of A on top. Okay, so this piece right here is this piece right here. All I did was use the change of base rule in order to get me from log base 9 to log base 3. That's nice because I can tell you this is a 2, so I will end up with log base 3 of A times 1/2 over log base 3 of A. So that disappears, and I'd end up with 1/2. So that's clearly, something's, I think we're okay. Anyways, that's clearly the harder way to do the question, but that was the intention when the people that designed the question. So that's good if you can think about it Jeremy's way, but that's the other way to answer that question.